So today we're going to be looking into the chapter of Forces and Motion 2 and of the many subtopics, not many, but 4 subtopics in this chapter. But the main subtopic actually is probably going to be Hooke's Law. Okay, so a lot of our essay questions are going to be from there. Okay, let's begin with Kedah 2023. Diagram 11.1 shows a boy playing on a horse spring. Okay, when you see spring, then you kind of know that we are headed towards that direction, okay, of Hooke's Law. Number one is Hooke's Law. The other definition that you should also think about is elasticity. Okay, these are the two most commonly asked definitions. Hooke's Law, elasticity. I think we will cover elasticity in a while, but let's go to Hooke's Law first. Okay, so Hooke's Law states that the extension of a spring is directly proportional to the force applied. Okay, but there is a condition for this. Okay, I noticed that a lot of definitions, especially when it comes to law, okay, when it comes to law, a lot of the Form 5 definitions for law, after you state the relationship, there's always a condition for it. For example, Ohm's law. Okay, in electricity, Ohm's law, potential difference is directly proportional to current. Okay, but the condition is as long as it follows, as long as it's an ohmic conductor, okay, the physical state is the same, and the physical state and something is constant, okay, but there's a condition set to it. So likewise with Hooke's Law, the relationship is the extension is directly proportional to the force. Okay, but the condition is if it does not, okay, selagi dia tidak melebihi the elastic limit. Okay, so there is a condition that is set to it, okay, that the force is not exceeding the elastic limit. Okay, therefore, then this will be Hooke's Law. Okay, extension is directly proportional to the force applied if it does not exceed the elastic limit. Okay, 11.2a shows the original length of spring before a load is placed on it. So this before the load. 11.2b shows the same spring after the load is removed. Means kau letak sudah itu barang kan, dan lepas tu kau kasih alihkan, and the spring we notice it does not go back to its original position. So the question is, explain the changes of the condition of the spring. Okay, so in order to answer this, remember this is a 4-mark question okay, so you need at least 4 points. Okay, so so you first have to mention that what are the changes. Okay, number one is that after you put the load on it and then you remove the load, it's supposed to go back to its original situation. It's supposed to go back to its original state, which is this one. This is the original state. But we notice that it doesn't. Okay, dia lebih pendek daripada yang asal. Okay, so that means the biggest change over here is that the spring has lost its elasticity. Okay, so the first point you have to state the changes okay, the changes of the condition of the spring. Number one, the spring does not return, okay, to its original position or original length. Okay, the spring does not go back to its original position or original length after the load is removed. Okay, so that's one. And then of course you want to explain why that happens. Okay, so we go back to Hooke's Law on this. Remember that Hooke's Law states that extension is directly proportional to the force as long as it does not exceed the elastic limit. Because once it exceeds the elastic limit, that means number one, that the spring has lost, okay, its elasticity. Okay, or the spring is no longer elastic. It's the same meaning. Okay, no longer elastic. That's why it cannot go back to its original position. Okay, and so then the question becomes, why does the spring lose its elasticity? Okay, so we go back to Hooke's law. It loses its elasticity because the weight that you put on it, the load that you put on it, has exceeded the elastic limit. Okay, so that's the third point. Okay, the load on the spring, the load on the spring has exceeded the spring's elastic limit. Okay, dia melebihi dia punya had. Every spring, everything that is elastic has its own limit one. Okay, so say for example the spring the limit is, let's say 1,000 newtons lah. Then you're going to put 1,500 newtons on the spring. It's not going to be able to go back because you are already putting it over its capability, over its ability. Okay, so that's the third point. The load on the spring has exceeded the spring's elastic limit. Okay, so because of that, the natural flow is not elastic. So because the load has exceeded the spring's elastic limit, and when you say that the spring has lost its elasticity, okay, and you want to relate it to the correct physics concept, which is Hooke's law, so then you have to say that the spring no longer obeys Hooke's law. That's the fourth and the final point. Okay, the spring no longer obeys, okay, mematuhi Hooke's law. Okay, so that's the 4 points. Number one, spring does not return to its original position, okay, after the load is removed. Number two, because of this, the spring has lost its elasticity. And number three, the load on the reason why it's lost its elasticity is because the load is beyond the elastic limit. Okay, and this causes the spring to no longer follow or obey Hooke's law. Okay, that's the 4 points with regards to this question. Okay, sorry, for those of you who just entered, we're at the Kedah 2023 paper for forces and motion 2. Okay, this is the first question, so not to worry. Okay, 11.3 shows the two conditions over here. Okay, A, initial length of A and B. 11.3b shows you what happens to the spring. Okay, after it is put by 100 Newton, this one. Okay, notice the condition of the spring, etc., etc. Okay, so by using diagram 11.3a, 11.3b, compare the initial length of the spring, number one, thickness of the spring, number two, compression of spring, number three. So three things to compare. Okay, compression is pemampatan berapa banyak dia mampat. Okay, then after that, the two things to relate. Relate the thickness of the spring and the compression of the spring, number one. To make a deduction regarding the relationship between thickness of the spring and the spring constant. Okay, so 5 marks, 5 points. Okay, once again, I want to remind all of you, don't worry about this word deduction now. Okay, it's just a fancy way of saying, make another relationship. Okay, so don't be too hung up. Apa ini deduction ni? Then you start to think about maths. No need. Okay, just compare and relate question is just compare and then write relationship. Sometimes it's one relationship, sometimes it's two relationships. Either way, it's going to be 5 marks. So you always need to have 5 points, okay, when it comes to this. All right, initial length of the spring, since both the spring have the same length, okay, so the initial length of the spring will be A equals to B lah. Okay, the initial length of spring A is equals to initial length of spring B. The thickness of the spring, I think it's very obvious over here. You can see it for yourself. Okay, thickness of A is bigger than the thickness of B. I think this is not a problem. Okay, A is bigger than B. Compression of the spring, take a look. Who is more compressed? Okay, these are very careful. Siapa yang lebih dimampatkan? Okay, B is bigger compression. Okay, dia lebih turun ke bawah. Okay, so I'm going to write A is less than B. The compression of A is less than the compression of spring B. Okay, so relate the thickness of the spring and the compression. I think this is quite easy. when you find that the spring is thicker, the compression is smaller. Okay, so the bigger, sorry, I'm going to write the shortcut lah. The bigger the thickness of the spring, the smaller the compression of the spring. Okay, the bigger the thickness of the spring, the smaller the compression of the spring. And then the relationship between the thickness and the spring constant. Okay, so this is the only one that you have to know the physics behind this lah. Okay, daripada 5 markah ni kan, 4 markah, you can get this from just observing. Okay, just observe the situation over here. Okay, so of course, in terms of the spring constant, okay, you have to remember this lah. The bigger the thickness of the spring, the bigger the spring constant is normal. Okay, bigger spring constant means susah dia mau mapat. Bukan susah dia mau mapat lah, it's harder to compress lah. Okay, so just some extra notes. Bigger spring constant means harder to extend or harder to compress. Okay, because it's thicker lah, thicker spring. I think it's very natural, quite easily understood. Okay, susah untuk kau kasih tarik. It's hard for you to pull it apart or to press it because it's very thick spring. Okay, and because it is harder to extend, okay, the elasticity okay, is less. It's harder to go back to its original position. Okay, let's continue. Okay, 11.4 shows a sofa that uses springs as a load supporter. Okay, so this is a spring sofa or a spring chair, I guess. Okay, using appropriate physics concepts suggests the use of materials and appropriate design of the sofa. And the reason for this is you want to accommodate a person with a larger mass like me, okay, and remain more comfortable. Okay, and the only thing they give you is the characteristics of spring and additional features. Wow. Okay, it's really not much to go on, but there are so many things that you can say about this. Okay, you can talk about the thickness of spring, the length of the spring, the diameter of the spring constant, many things about this. Okay, now for those of you who have the black book, okay, this is page 30 and 31 in the black book. Okay, you can actually refer to this in the black book. Okay, but for the sake of our discussion today, let's give the answers as well. Okay, so number 1, okay, is if you want to talk about the material of the spring, okay, we always start with the material. Since you talk about characteristics, you can include the material. Okay, you can say steel spring. One of the better springs there, okay, is a spring made out of steel. Okay, or even stainless steel. Stainless steel is even better. Okay, stainless steel spring. Okay, either one of these is also better. And there are many reasons for this. Okay, you can say last longer. Okay, stronger. Okay, does not rust easily. And the equivalent to does not rust easily is a low rate of oxidation. Okay, low rate of oxidation. Okay, these are standard answers. Okay, for steel spring. Okay, number 2. Okay, number 2 is you want a spring that is short. Okay, not too long because too long means it's too elastic and not good. Okay, so a short spring. Okay, a short spring, then usually short spring is related to the spring constant. Okay, so high spring constant. Okay, and for discussion purposes, high spring constant is always, it's always talking about stiffer spring. The higher the spring constant, therefore you have a stiffer spring. Stiffer spring means it can accommodate a bigger load. Okay, so but of course you cannot write the bigger load because it's in the question. It can accommodate a person with a bigger mass. Okay, so another way to write the words accommodate a person with a bigger mass or bigger force, okay, is you can say small compression, smaller compression. Okay, this is another way to say can accommodate a person with a bigger mass or bigger force. Okay, orang yang beratnya lebih tinggi okay, maksudnya dia punya mampatan itu kecil lah. If it is a very big compression If it is a very big compression, means the moment you sit down on the chair, you will start to sink down, because it compresses very easily, and you don't want that lah, obviously, because that's not the kind of sofa that people want to sit on. Okay, people want to sit on comfortable, yet not like keras sampai langsung tidak boleh turun lah. You can compress but a little bit. Okay, just enough to give you that amount of comfort. Okay, a third one, okay, will be small diameter of spring. Okay, small diameter spring. Okay, and actually, technically, the reasons for this are the same as the above. Okay, same reason. Big spring constant, you have a stiffer spring, okay, and then you have smaller compression. Okay, generally the same this one lah, small diameter of spring. Okay, when we say small diameter of spring, I'm not talking about the wire itself. Okay, I'm not talking about the wire, but I'm talking about that hole. Okay, that diameter we're talking about lah. If you're talking about the spring wire itself, then you're not actually talking about the diameter. Okay, you're talking about the thickness of the spring. So the thickness of the spring, of course, if you've been following this one, you definitely want a thicker spring, of course. It has less compression. Less compression means can support more. Okay, so you can say thicker spring wire. Thicker spring wire or big diameter of spring wire. Okay, so I don't want you to be confused by point number 3 and point number 4. So satu small diameter, satu big diameter. Number 3, small diameter of the spring is itu lubang itu. Okay, the lubang in which the spring is, that one is the diameter of the spring. But the spring wire itself adalah dia punya wire sendiri lah, ketebalan spring itu sendiri. Okay, that's called the diameter of the spring wire. So it's two totally different things now. Okay, one is talking about the hole, one is talking about the wire, but the reason can be the same. Okay, higher spring constant, stiffer spring, smaller compression. Okay, and therefore it can support a bigger load. Okay, and since we're on this, we can also talk about spring constant itself. Spring constant is a characteristic. Okay, so high spring constant. Okay, a high spring constant, unfortunately, you cannot use the first point over here lah. Okay, you have to use stiffer spring or smaller compression. Okay, actually, if lah, kalau bukan sebab the question has given to us, it can accommodate a person with a larger mass. Okay, you can actually write support a greater load as one of the reasons. You can actually write that as one of the reasons, but unfortunately, it's already in the question, so you cannot use that. Okay, you cannot use that for your this one lah. Okay, so higher spring constant, so that you have a stiffer spring, smaller compression. But I think it's a good idea to keep this answer in mind. Okay, when you're doing Hooke's law, okay, if let's say this year the question is Hooke's law question, have in mind one of these reasons as well, support a greater load. Okay, so that you can have variations of the same answer. Or if you want to write the same reason for all, actually I don't think it's a problem to write the same reason. Okay, but I think it's a good idea to have more than one kind of reason, although they all mean the same thing. Okay, other possible answers will be the arrangement of the spring. Okay, remember that there are two kinds of arrangements. One is a series spring arrangement, and one is a parallel spring arrangement. Okay, so obviously we want the parallel spring arrangement lah. Okay, so the answer for this will be parallel spring arrangement. Okay, and once again the answers will be the same lah. Higher spring constant, stiffer spring can support a greater load. Okay, after a while it's very boring lah. Okay, okay, additional features. So right now we have talked about the characteristics of the spring. Okay, we need to put at least one additional feature lah. Okay, and remember the point is can accommodate a person with a larger mass and more comfortable. Okay, so how do we make a sofa that is more comfortable? Talk about the material itself lah. Okay, so sponge. Okay, I think it's in the black book. Sponge on top of the spring. Okay, sponge or soft material lah. Okay, you don't want the person to sit on the spring itself lah, and there has to be a layer. So you put a sponge, put a cushion, okay, on top of the springs. Okay, and the reason for this is to increase the time of impact. Okay, and this, whenever you talk about sponge, this talk about impulsive force a little bit lah. Okay, to increase the time of impact. Another one, and this one I got from the marking scheme, is to use the cover. The cover for this one, okay, the sofa cover, okay, is made of fabric, okay, or leather. Okay, the sofa cover or the sofa liner is made of fabric or leather, but you cannot say it's more comfortable lah. Okay, so there are many possible for this one. Okay, there are many possible reasons lah. Why is it this one? You can say that it's a softer material. Okay, you can also say it heats up slower. Okay, comparatively lah, okay, I know leather sofa seats usually heat up faster, but they also cool down faster. Okay, but I mean, as opposed to steel or metal cover, right? Okay, leather fabric, generally heats up slower lah, so it takes a longer time, so you stay cool longer. Okay, but these are the possible reasons for this lah. As long as you don't put the words in the answer, in the question, okay, it's more comfortable. You cannot say that because it's already in the question. Okay, so these are the possible answers for this. I think there are more answers in page 30-31. Okay, but 30-31 actually doesn't have the sofa lah. Okay, but the principle behind this question is there. Okay, it's in page 30 and 31. Okay, the most important thing which I think I need to highlight lah, okay, is that in the question it is asking for characteristics of the spring and additional features. Okay, what I've given you is 1, 2, 3, 4, 5 characteristics of the spring. Okay, and then the other 6 characteristics of the spring. Okay, and the other 2 are the additional features. Okay, so you need to write at least 3 lah. Okay, you can do a combination of 3 plus 2 or 4 plus 1. Jangan tulis semua pasal characteristic of the spring because kamu akan hilang markah in terms of the additional features. So again, when you're answering these kind of questions, be aware. Okay, be aware of the fact that you need to have at least 5 points. Tetapi setiap ciri yang diminta dalam soalan mesti kau bagi sekurang-kurangnya 1. Okay, so in this case, it's either 3 characteristics of spring, 2 additional features, or 4 characteristics of spring and 1 additional feature. Okay, don't worry about the S. The S is a small matter. Okay, but at least 1 additional feature. Okay, in order for you to be able to get the full 10 marks. Of course, if you can remember all 8 of this and you want to write all 8, go ahead. Okay, I don't see why not. Mana tahu kan ada yang kamu termiss, at least kamu ada jawapan lain yang kamu boleh backup lah. Okay, in this case. Alright, let's move on to Perlis 2023. So this is the second type of question that is quite highly possible for this year with the equilibrium of forces. Okay, when I did the analysis, I noticed that most of the questions are either Hooke's law or equilibrium of forces. So maybe 1 or 2 questions about resultant force lah. Okay, but we'll talk about this in a little while. Okay, so the 2 photo frames over here, is using a 60-degree angle, one is using a 45-degree angle. Okay, what is meant by the equilibrium state? Equilibrium state is a state where all the resultant forces, or the resultant force lah, okay, acting on an object is zero. Okay, the total force acting on an object is equals to zero. Okay, that's equilibrium state. This seems to be a pretty popular definition lah, okay, for this year. All right. Okay, B, in the space below, draw a diagram of the triangle of forces that acts on two frames. Okay, most importantly is this. Okay, question says that the two photo frames are in equilibrium state. Okay, and that's a very, very important statement because it tells us that if we want to draw a triangle, okay, somehow that triangle, whatever way that we draw the triangle, the flow of the forces must be in one direction only. Okay, this is an equilibrium triangle. But if it is a resultant force triangle, okay, if it is a resultant force triangle, okay, you may have the same kind of triangle, except that two of the forces are in the same direction, and then the last one is on the opposite direction. Okay, and this is the resultant force. Okay, there are two kinds of triangles that you need to know in this chapter. One is the equilibrium triangle, in which all the three forces go in one direction. Okay, and then the second one is the resultant force triangle, where two of them are in one direction. The resultant force is the one that is going in the opposite direction. Okay, of which the more important one to focus most likely this year is the equilibrium triangle. Okay, the fact that all three are in one direction. Okay, so you have T1 that is going 60 degrees to the right, T1 that is going 60 degrees to the left, and don't forget there is a third force over here, which is the weight, okay, which is going onwards. Okay, so one possible way, okay, in 7.1a will be T1 over here, and then another T1 over here, and then you have the weight. Okay, this is W, T1, T1. Okay, and then because of that, this will be 120 degrees now, because with the flat line, okay, it is 60 degrees. Okay, so 60 degrees here, 60 degrees here. Okay, kalau saya lukis satu garis begini, dan ini akan jadi 60 darjah, which is the same situation as this. Okay, manakala over here, this is T1 going on top to the side over here, this is 60 degrees. Okay, now either way either way, if you cannot remember this, okay, because I know this is, we are all planning for exam. Astaga. Okay, just remember that the angle between the two T forces is the sum of both 60 and 60. Okay, the angle between the two is 60 and 60. Okay, so and because of this, ini akan menjadi, kalau sini 120, ini dua mesti sama lah. Okay, 180, this will be 30, and this one will also be 30. Okay, the second triangle, also the same, except the angle is different lah, 45 and 45. So, bila kita campur dua-dua bersama, dia akan jadi 90. Okay, so you have T1 over here, and then T2 over, T1 also, T1, or T2, sorry. T2 over here, T2 over here, and we know that this is a 90-degree angle. How do we know this? Because 45 plus 45 is 90. Okay? If you know the maths behind this, good for you. If not, just remember it as it is. Okay? Don't be too hung up on this. All right. So once you get this as 90, and then of course W will be downwards lah. Okay, now remember that this doesn't have to be exact science lah. Okay, they are not going to take a protractor and then, measure betul kan ni 120. You can just roughly draw. The most important thing is the direction of the direction of the forces. Okay, they must go in one direction. Okay, dan dia mesti ikut beginilah. Okay, they must follow this direction over here. Okay, and remember that W is downwards. Okay, it's a 2-mark question lah. Okay, there's really not that much to it. The most important thing is this angle over here. Okay? This angle and this angle. So if this is 90, then this will be 45. This will also be 45. Okay, complete the triangle to its fullest, okay, which includes the angles in order for you to get the full mark. Okay. All right. Table 7.2 shows 4 lawn mowers. Okay. Lawn mower question. Lawn mower question is also in the black book, I think. Yeah. Okay. This is page 23. Yeah. If you have the black book, okay, page 23 in the black book will give you the answers. Okay, but it's all here lah. So, based on 7.2, okay, state the suitable characteristics of the most suitable lawn mower to cut the grass effectively. Okay, there are two methods of moving. Either you're pushing or you're... Sorry, this should be pull. Okay, this should be pull. But either way, okay, the better method of this one is the push method lah. Okay, and the standard answer for the push method is to produce a greater force. Okay, to produce a greater force on the grass. Okay, so that you can push the grass more so that it gets cut easily lah. Okay, you don't want to pull it up because if you pull the lawnmower, then you know essentially the itu pemotong okay will be lifted up. It's very hard to cut the grass. What's the point? Okay, the size of the cutter blade, you have two choices: small size or big size. Okay, obviously you want big size lah. Okay, bigger size of the cutter blade, and the reason for this is more grass can be cut. Okay, in a shorter time. Tidak payah kamu buang masa lah cutting the grass. Okay, what you don't want to answer is this one lah. Okay, to cut the grass effectively. So you don't want to have that as your answer. Okay, just remember that. Okay, the angle between the handle and the horizontal line, either a smaller angle or a bigger angle. If you remember the resultant for this one, you obviously want a bigger angle. Okay, bigger angle, and the standard answer for bigger angle is to produce a larger downward force. Okay, standard answer. Bigger angle is to produce a larger downward force so that your grass cutter gets pushed down even more. Okay. I think that I forgot to write the D question. Yeah. Okay. So which is the most suitable? Sorry, I think I didn't photostat this. Which lawn mower is the most suitable? Okay, and between P, Q, R, and S, you want it to be push, bigger angle, and bigger blade, makan. Okay, push, bigger angle, and bigger blade. So you want to have S. Okay, S is the most suitable for this. Okay, because it fulfills all the characteristics above. All right, let's go on to the Melaka question. Okay, Melaka, this is also another question, number 7. Okay, diagram 7.1 shows a worker cleaning the floor with a mop. Force acted on the mop is labeled as F. Okay, and F is in this direction. Okay, take note of this lah. Okay, so in diagram 7.1, sketch the resolution of forces. Resolution of forces means they give you one force, and then you have to split it into the two components. Okay, so we look at this direction. This direction is down and left. And dia bawah dan ke kiri. So those are the two forces. Okay, so the two directions that you want to draw, number 1 is a downward force. Number 2 is a leftward force. Okay, that's it. They didn't ask you to label it, but I think it's good to label. Downward force is called Fx, and the leftward force is called Fy. Okay, everybody, there are only 4 directions in which this force can be resolved. Okay, number 1 is this one. Okay, this one will be up and right. And we resolve the forces. Red color is resolve. The second direction is like this. Okay, this will be up and left. This Fy, this Fx. Okay, kiri dan atas. This is really not difficult. Okay, just pisahkan the sengit into 2 straights. Okay, the third one is this, down and left, and then the last one is in this direction lah. Okay, this one will be down and right. Okay, these are the only 4 possible directions. Okay, in geography also you learn this lah, kan, timur laut, barat, dan semua itu tenggara. Okay, so it's not necessarily very difficult lah. Okay, there's only 4 directions. Just remember that the resolved forces is either up, down, left, right, and everything else is just saying it. Okay, calculate the magnitude of the vertical component if this angle and the horizontal component, sorry. So you want Fy and Fy. If this angle, okay, this angle over here is 65 degrees, which is the question. Okay, now remember that the components are either F sine theta or F cos theta. Okay, there are only 2 possible situations for this. So the question that you have to ask is, which one is F sine? Is it the horizontal one or is it the vertical one? Okay, which one is the F sine? And everything depends on where the angle is touching. Okay, if the angle is touching the horizontal, okay, if the angle is touching the horizontal, then the horizontal one is F cos theta. Okay, manakala this one becomes the next one, F sine theta. Okay, sorry, let me just double check this again. If the angle of theta is 65 degrees. Oh, sorry, I made a mistake. This should be Fx. This is Fy. Sorry. So X adalah mendatar. Sorry, my bad. Okay, so the horizontal component is cos because the angle is touching the horizontal component. Okay, so this one, angle touches this. Okay, kalau sudut yang diberi itu is the one that is touching that particular component, that component is the cos one. Okay, so because of that, Fx is 50 cos 65. Okay, manakala Fy is 50 sin 65. There are only 2, cos and sin. Okay, so this one will give you the answer of 21.131 Newton, and Fy will be 45. Oh, sorry. Fy will be 45.315 Newton. Okay, lebih kurang begitulah. Okay. But the most important thing is, I don't want you to memorize, oh, X is cos, Y is sin. Itu jangan. Okay, that's very dangerous because they will not necessarily give you this angle di sini. Okay, it's just that, remember, whichever component the angle is touching, that is the sine, the cos component. Okay, so kalau 65 itu menyentuh Fx, then X is F cos theta, F cos 65, 50 cos 65. Okay, if the angle is on the other side, then the other side punya one is cos. Okay, because if you remember your trigonometry, cos is C is A over H, adjacent. Okay, yang bersebelahan dengan sudut itu adalah cos. Okay, so we're taking from this thing that you learned in trigonometry the last time lah. Okay, remember this. The angle always touches the cos component. Once you remember this, I think it should be not a problem. Okay, what is the meaning of the resolution of forces? Resolution of forces is the splitting of one force to its components. Okay, resolution of forces is the process lah. Okay, process of resolving okay, a single force to its components, component forces lah. Okay, bukan gabungan lah, okay, dia pemisahan. Okay, because daripada satu daya, you can split it to become at least two at different levels, maybe 3 or 4 or more. Okay, the process of resolving a single force to its component forces. C. Diagram 7.2 shows a child playing a slide in the playground. Oh, wow. Okay, characteristics of slide, type of surface, angle of inclination. Okay, I think this one is quite easy. But let's look at the reason first. Oh, most suitable. Okay, I guess most suitable is the most fun one. Probably lah, most fun lah. Not safety lah. Okay, so smooth or rough, obviously you want a smooth one lah. Okay, angle of inclination, you want a small one, a big one, obviously you want a big one. So we're headed towards R lah. Okay, so you want a smooth surface. Okay, and smooth surface usually is to reduce friction. Okay, and by extension, if you reduce friction, you increase acceleration. Okay, then in increasing acceleration is, you know, the same as having a lot of fun. Wow. Okay, angle of inclination will be big. Okay, bigger angle of inclination, because the higher you are, the faster you can go down lah. Okay, so you can either increase acceleration or you can have a same like the lawnmower just now. When you have a bigger angle, you can increase the downward force. Okay, produce a bigger downward force. And when you have a bigger downward force, then you slide down faster lah. And when you slide down faster, you have more fun. Okay, so the most suitable slide is R. Okay, in our situation over here. I don't know why they give 2 lines for just 1 letter lah, but yeah, up to you lah. Okay, as long as you answer the question, don't worry about the amount of space that you have. All right, next question. Negeri Sembilan. Again, Negeri Sembilan 2023. This question number 2. So number 2 usually is a factual question. Some calculation is probably involved here. Okay, so just take note of this lah. Diagram 2 shows a vehicle being pulled by using 2 ropes with a constant velocity. Okay, this is a very important thing. Okay, and something that I keep harping on lah. Constant velocity means 0 acceleration. Okay, this is the partner lah. Okay, now if it is 0 acceleration, it also means another thing. 0 acceleration means the force is 0. The resultant force is 0. Okay, because according to F equals to ma, if the acceleration is 0, makanya the force is 0 lah. Okay, this very natural conclusion. And we heard from the previous question that if the resultant force is 0, what does this mean? Resultant force is 0 means that it is in equilibrium. Okay, the equilibrium of forces is happening over here. So again, now we see this equation, but it is very subtly mentioned. Okay, of course, the soalan pertama force in equilibrium lah, but how do you know? It's because constant velocity. Constant velocity means 0 acceleration. 0 acceleration means resultant force is 0. Resultant force is 0 means that the forces are in equilibrium. Okay, so I'm going to ask you to refer to the Perlis question because the answer is the same lah. Okay, force in equilibrium is where the resultant force is equal to 0, etc., etc., etc. Okay, now diagram 2 draw a vector diagram that represents the forces T1, T2, and FF. Okay, FF, okay, acting on this. Okay, FF is here. So T1, T2, and FF. Most important thing is that all 3 forces must be in one direction. Okay, so I think the best way to draw this will be T1 and then sambung T2, and then after that FF to the back like this. Okay, but you have to get the angles correct lah. So T1 is over here. Okay, and according to this angle is 20 degrees. So this is not a problem lah. Okay, this is a 20-degree angle. T2 is over here. Yang ini yang kita tidak tahu. Okay, okay, and we know that FF is to the right. Okay, so since this is T2, this will be 40 degrees. Okay, as shown in the direction over here lah. Okay, because if you remember your maths, okay, kalau saya lukis satu garis di sini, bahkan this angle and this angle is the same, 40 degrees. Okay, so this will be 40. Therefore, you're left with this angle, which is 160. Sorry, 60, 120 lah. Okay, 120 degrees. Okay. Again, when you draw the triangle, all three directions must be shown, and if possible, and actually you should, it's not even if possible, you should, okay, show all three angles in order for you to get the full marks. I know some people will say just draw two angles is enough already, but I think you should just draw three lah. Okay, it's not that difficult to count. Once you know the 20 and the 40, you can calculate the 120. Okay, so draw all three lines and all three angles in order for you to get the full mark. Okay, then, oh, sorry. There's a missing question again, sorry. I think, okay, it's either calculate T1 or calculate T2. Okay, so you know what? Let's assume okay, let's calculate the value of T1. Let's do T1 first, I think. Are the angles given? No. Hold on. Oh, they don't give you this one. Hold on. Oh, okay. Calculate the value of T1. Given, okay, given F is equals to 950 newtons. Sorry, I think there's a missing question over here. Okay, given that FF is 950 newtons. Okay, calculate the value of T1, and by extension, you can also calculate the value of T2 lah. Okay, now this is a situation where kalau di sini adalah 950, okay, you have these two and you want to find this one and you have this angle. Okay, then you know that you have to use the sine rule over here lah. Okay, so T1 over sine 40 equal to 950 over sine 120. Okay, this will give you the answer T1 equals to 705.116 newtons. I think so. (950) divided by sine 120 times sine 40. Yeah, 705.115 newtons. If they ask you to calculate T2, okay, same idea lah. Okay, T2 over sine 20, because the angle is 20 opposite, equals to 950 over sine 120. Okay, so bring the sign across. 950 divided by sine 120 times sine 20. You should get about 375.184 newtons. Okay. Either way, usually in a resultant force situation or even in a triangle situation, we try to use sine rule. Okay, unless you're very desperate. Okay, if you're very, very desperate, then yeah, no choice that you use cos rule. But I think sine rule is good enough. Okay, let's move on. We're going to Pahang. Okay, Pahang 2023. It's question number 3. So number 3 is 4, 5, 6. Question number 3 is 6 marks. So, but again, definitely calculation, some explanation may be involved over here. Okay, name the force in diagram 3. If there's a weight, the opposition of weight will be a lift force. Okay, what you don't want to answer is a normal force, because normal force means there must be a surface. Okay, for example, an object like this, right? The force downwards is the weight, and the force opposite the weight is a normal force. Tapi normal force must have a surface. Okay, in this case, the drone is hanging in mid-air. There's no surface involved there. So, once again, okay, it's a lift force, okay, that's generated by the drone. Another thing to point out is that we are talking about uniform velocity, same situation as you did now. Uniform velocity means equilibrium of forces. Okay, equilibrium of forces because zero acceleration, resultant force is zero, etc., etc., etc. So state the mathematical equation that relates the force weight and h. Okay, since it is in equilibrium because uniform velocity, okay, so the weight, okay, equals to h. Okay, why? Because this one is forces in equilibrium. Oh, actually, no, you know what? It's called equilibrium of forces. Oh gosh. Equilibrium of forces. Okay, so equilibrium forces means atas sama dengan bawah lah. Okay, the drone is then accelerating upwards, okay, with an acceleration of 0.2. Okay, so let's consider this situation now. Accelerating upwards means there's a force upwards and there's of course the weight lah. Okay, so most important thing is that since it is accelerating upwards, so that means the force minus the weight. The force is bigger than the weight. Okay, so that means force minus the weight equals to mass times acceleration. This is from Newton's second law, F equals to ma. But F, remember, is the net force. Net force means kalau ada acceleration, we have to consider which is the bigger force, which is the smaller force. In this case, since dia naik ke atas, the bigger force is upwards lah. Okay, so I'm just going to call it F up lah. Okay, well, I guess if you want to call it a lift force, I will call it H lah. Okay, H minus W equals to ma, also the same thing. Okay, so because they asked for H pula kan. Okay, so the weight, you can calculate the weight lah, because the mass of the drone is 0.4 kg. Okay, so what is the weight of the drone? The weight of the drone is 0.4 times 9.81. Okay, which is 0.4 times 9.81, 3.924. Okay, so H minus 3.924 equals to the mass of the drone 0.4 times the acceleration, which is 0.2. Okay, so you calculate this, you get H equals to 4.004 newtons. Okay, it's a pretty simple calculation lah. Okay, as long as you know the concept of equilibrium of forces. Sorry, lift force. Okay. All right, next question. Next question. Okay, sorry everybody, this is wrongly placed. This is actually supposed to be for tomorrow's class. So actually we have 2 more questions to go. Okay, sorry, this is for tomorrow's class. Sorry, not tomorrow, the day after. Okay, the next class in pressure, I will cover this question first. Okay, so yeah, I'm very sorry I placed this in the wrong chapter. This is supposed to be under the chapter 2 question, okay, which is pressure, which I will cover in the next class lah. Okay, so please take note. This question is under pressure, and we will discuss this question first, okay, in our next class before we move on to the actual pressure punya this one lah. Okay, so sorry, I don't know why I put this over here. I think because I saw the force gun, because I thought, oh, this must be forces equilibrium. Then when I look at it again, oh no, this is actually Bernoulli's principle. No, Archimedes' principle. Okay, so anyway, let's move on. Okay, Sekolah Menengah Kebangsaan Agama SMKA 2023. Okay, same situation as just now, the picture situation. Okay, so forces in equilibrium as mentioned in the question over here. Okay, except that now they give you the rope tension 2.289, the other one is 4.302. Different angles, one is 40 degrees, one is 20 degrees. So state the meaning of force in equilibrium, refer to the previous question again. Okay, so I've already given the answer there. Basically, resultant force is 0 lah. Okay, all you have to mention that. Okay, based on diagram 6.1, 6.2, compare the angle. Okay, good question is, I mean, this is an easy question to compare. Okay, obviously you can see over here 6.1 is bigger than 6.2. Okay, the tension, one is 2.289, one is 4.302. So 6.1 is smaller than 6.2. Ini boleh lah, quite senang. Quite easy to see. Okay, and the third one is the weight of the picture frame. Since they both have the same mass, 0.3, 0.3, so the weight must be the same. Okay, same mass, same mass, same weight. Okay, based on the answer in 6B, state the relationship between the angle and the tension. Okay, notice that both of these, the direction is different. 6.1 more, 6.1 less. So the bigger, the one bigger, one smaller. Okay, so in this case, it will be the bigger the angle, okay, the bigger the angle theta, the smaller, okay, the tension of the string. T. Okay, bigger angle, smaller tension. I think it's quite simple lah. Okay, so based on the observations in 6B and 6C, okay, make a conclusion about the appropriate method. Okay, appropriate method will be, do you want to use a smaller angle or the bigger angle? Obviously, you want a bigger angle lah. Okay, use the bigger angle method. Because bigger angle means smaller tension. Tengok. Kalau kita guna sudut yang lebih besar, our tension is smaller. When the tension is smaller, it won't snap so easily. Okay, kalau besar dia punya tegangan, bahkan dia sangat senang untuk snap. Okay, and the point of this is you want to prevent the string from breaking quickly. Okay, so use the bigger angle method. If the picture frame in 6.1 is replaced with the same size picture frame, same size, but the mass is 0.5 kg. What? Mass is 0.5 kg. Calculate the tension in the string T. So this is here, this is the weight lah. Okay, so you have T1, T over here, this is T over here, and this is the weight. Okay, the weight is 0.5 times 9.81, which is 4.905. And this is 80 degrees. Okay, we established from the Perlis question just now that since it is 40 and this is 40, okay, and it is in equilibrium, it will be 80 degrees lah. Okay, so you want to calculate T. Okay, if this is 80 degrees, then you know that this is 50 degrees, and this is also 50 degrees. So you can use either the sine rule or the cos rule. I guess using the sine rule is better lah. Okay, if you want to calculate the tension T, so T over sine 50 equals to W, W over sine 80. So T equals to 4.905 over sine 80 times sine 50. 4.905 divided by sine 80 times sine 50. 3.815. Yeah. 3.815 newtons. Yeah. Okay, so once again, we are dealing with a question where we have to use the sine rule, okay, and the equilibrium of forces. So actually, if you are looking at this, if this question comes out as a structure question, okay, I think you have to be prepared for the fact that, first of all, you have to know how to draw the triangle. And secondly, you need to know how to use the sine rule. Okay, which I think for all intents and purposes is quite good lah. Okay, if you can get 3 marks from this, I think it's good enough. Okay, but I think more importantly than that, and I think depending on where you are at your learning stage, the more important thing to grasp, okay, yang lebih penting kamu kuasai is macam mana mau lukis itu segi. Start with the triangle first. I think that one is more important. Once you have mastered how to draw the triangle, then you can move on to doing the calculation lah. Okay, which generally a lot of people don't like. I know. Okay, a lot of people don't like calculation questions. If you're aiming for the A and the A plus, you need to know to do some calculation questions. Okay, especially if you want to aim for A minus. Okay, A plus, sorry, I have to know everything. Okay, but A minus, I think if you do just triangle and some minimal calculation questions, you should be able to be fine. Okay, don't worry about it. Why is the angle 15? Oh, because first of all, this angle over here is 80 because we established from the Perlis question just now that if this angle is 40, okay, therefore the angle between T1 and T2 is the combination of 40 plus 40, so it gets 80. Okay, and then when this is 80, since these two are the same tension, so it is an isosceles triangle. Isosceles triangle means you're left with 100 divided by 2, so this one will be 50. Isosceles triangle. Sorry, in short. Okay, I hope that answers the question. Okay. If you're ever in doubt, because I explained more about this when we were doing the Perlis question just now. Was it the Perlis question? Yeah, I think it's the Perlis question, this one. Yeah. Okay, we are saying that these two angles over here, the angle in between it is the sum, 120. So that's how I naturally get this 30 and this 30, because 180 minus 120 is 60. 60 divided by 2, because it's an isosceles triangle, okay, it will be 30 and 30. But this is, again, everybody, this is a situation where both the tensions are isosceles. As in, both the tensions are the same. Okay, like in the case of this one, dua-dua T1 and T1 is the same tension. This is the same string. Okay, but if you look at this question just now, the one in the car, this one, you cannot say that T1 and T2 are the same. Okay, because it's being pulled by two different forces. So this is a different situation altogether. Although it is the same kind of triangle, sort of okay, but it is a different situation. You cannot assume that it's isosceles. In this situation, okay, in the picture frame situation, we can wow, sorry. In this situation, we can assume that it's an isosceles because both T1 and T1 are held by the same string. So same tension, and same angle. So everything is the same. Okay, so we can assume that lah. Okay, and likewise in this case also, we are also assuming the same thing. Okay, thank you for the question. All right. Oh, this is the last question of the day. Oh. Okay, let's finish this. This is question number 11. Okay, notice that we've been doing a lot of question number 11, compare question, modify question. So if this question comes up this year, it seems to be headed in the direction of Hooke's law, okay, because if archery bow is usually Hooke's law. So it's a good idea to, do a refresher course on this. And I think I've given the pages in the black book, okay, for you to refer. Okay, an archer practices archery using the same equipment by applying an initial force F as shown in diagram 11.1, 11.2. Okay, you can see over here. When the arrow is released, it will travel at a speed due to the elasticity of the bow. So what is the meaning of elasticity? Okay, so just now I said in the beginning of the class, I said that one of the definitions that you have to remember is the Hooke's law. Okay, the Hooke's law definitions. Okay, and the other one is elasticity. Okay, which we're going to cover over here. Okay, so the elasticity is the property or a property of a material that enables the material enables it to return to its original shape or size, original shape or size after the applied force is removed. Okay, so this is the condition for the elasticity. Also, again, like Hooke's law, there's a condition, right? If the electric doesn't exceed the elastic limit, okay? If the force applied doesn't exceed the elastic limit. So the same like elasticity. Elasticity is a property of a material. Dia sifat satu bahan, okay, yang membolehkan, enables it to return to its original shape or size or length. You can also say length if you want. Okay. But after the applied force is removed, selepas kamu keluarkan itu daya, okay, yang bertindak ke atasnya, then if it can go back to its original shape, original size, original length, then it is an elastic material. Kalau dia tidak boleh kembali kepada keadaan asal, means dia sudah hilang dia punya kekenyalan. Okay, the elasticity is gone. Okay, so that's the definition. I think if you are going to study for this chapter, especially we're going to focus on Hooke's law, these are two definitions that you kind of want to refer to. Okay, so again, as I said, write all this down in the paper, okay, and as you go nearer and nearer to the exam, these are the papers that you should just be refreshing, okay? Don't read the black book anymore at this point. Sorry, I mean when it's very near the exam lah. Okay, just read through the answers, making sure that, okay, you know the answers for this, you memorize the definitions that you need to memorize, and then of course pray very hard that the same question or the same type of question will come out lah, okay, for your exam. Okay, diagram 11.1, 11.2, compare the initial force, stretching distance, and spring constant of the bow. Okay, force, quite easy. One is 250, one is 150. Okay, so the initial force F, okay, 11.1 is bigger than 11.2. Okay, the stretching distance, notice the distance over here, also the same, 11.1 bigger than 11.2. Okay, the spring constant of the bow, okay, since they're using the same kind of bow, okay, so the spring constant is the same. Okay, same bow. Okay, same bow, so the spring constant is the same. I think it's not that difficult. Okay, you should be at least number one, number two, please get it right. Okay, because there is very obvious lah. Okay, you can only get this wrong if you're blind. Okay, all right. State the relationship between the initial force and the stretching distance, and state the law that explains the relationship. Okay, so first of all, let's do the relationship. Since they're both in the same direction, okay, so you can say that the bigger the initial force, the bigger the stretching distance. Okay, the bigger the initial force, the bigger the stretching distance, and this is a law. Elasticity has only one law, which is Hooke's law. Tak payahlah fikir benda lain. Okay, because asal spring, asal, you know, tarikan tali ni semua, hanya satu law saja. Okay, which is Hooke's law. Even if you don't know what is the relationship lah, okay, just remember that, oh, this topic, kalau cakap pasal spring, pasal tali yang kena tarik semua kan, memang Hooke's law. Okay, 11.1, 11.2, which method will produce a further shooting distance? This one is really, you know, if you cannot get 4 marks, you must be able to get 1 mark. Okay, because the question is asking, kaedah mana yang akan memberikan, you know, the further shooting distance? Logic tells you that of course it's 11.1 because you're stretching more. Okay, so even if you cannot get all 4, don't be like, saya tidak tahu. It's not you don't know, no. You just think logically. If you pull more, definitely you can shoot further. Okay, so oh, I don't have space over here, so let me write down. Okay, so point number 1, okay, method. Okay, method in 11.1, okay, will produce, sorry, what's the question? Produce a further shooting distance. Okay, produce a further shooting distance. Okay, this is mark number 1. Don't miss this mark. Okay, even if you don't know what's happening, don't miss it because it's a very simple mark. Okay, method number 1, sorry, method 11.1 will produce a further shooting distance. Okay, let's talk about the explanation. When you pull this one, okay, what produces the further shooting distance is the energy lah. Okay, so talk in terms of the energy. Don't talk about the force. Okay, if you're talking about the force, then you're totally out already. because it is the force that gives you the energy. So when the string is pulled lah, okay, so when the string is pulled, is it string? Oh well, yeah lah, fine. When the string is pulled lah, okay, when the string is pulled, it produces a higher elastic, okay, potential energy. Okay, in 11.1, because you pull further, so you have an elastic potential energy. Okay, when the string is released, okay, the elastic potential energy is converted to, think about the energy. Bila kamu lepaskan and the arrow moves, asal dia bergerak, the energy involved is kinetic energy. Okay, is converted to kinetic energy. Okay, and then of course it moves further because in 11.1, bigger kinetic energy. Okay, the kinetic energy in 11.1 is higher and produces a further shooting distance. Okay, point number 4. So think in terms of the energy, because asal dia bergerak is kinetic energy. So you cannot be talking about the force anymore. Okay, the force produces the elastic potential energy. Elastic potential energy converts to kinetic energy. Kinetic energy makes it move even further. All right. We show all 4. And whoever wants to take a screenshot, this is a good idea to do it now, lah. Okay, because all 4 points are being shown. All right, let's move on to the last one. Oh, sorry. Hold on. Okay. Diagram 11.3 shows a cradle used to put a baby to sleep. Oh no, spring again. Okay. Sorry, did I say oh no? Never mind, same thing. Okay, cradle to put baby to sleep. I think this is a very, very standard question. But take a look. You are required to give suggestions to improve the design of the cradle so that it can accommodate a larger baby. Same as the so far question just now lah. Okay, so explain your recommendations based on the characteristics of the spring and the characteristics of the cradle frame. That's a cradle frame, so that it is safer and easier to use. So remember, it's either 3 plus 2 or 4 plus 1. You need to mention at least one characteristic of the cradle frame. Okay, so many possible answers to this. Okay, cradle frame is harder. Pretty much the so far question. Okay, the cradle frame, okay, you can talk about the fact that the cradle frame is made of steel, okay, or stainless steel, or hard material, so that it lasts longer. I think there's really no need lah. There's no need for me to give you the answers for this, because characteristics of the spring, we've already covered this right in the first question. Okay, when we're talking about this, you really cannot run very far from this. There are 6 points I've given over here. Okay, just use any of at least 4. At least 3, at most 4. Okay, don't give all 5. Okay, of course, if you want to override, go ahead and override, but make sure that the most important thing is that you write about the characteristics of the cradle frame. Okay, this is the cradle frame. Okay, ini bingkai ni. Okay, so you want the cradle frame to be a hard material, okay, so that it lasts longer, so that it can, as long as you don't say, jangan saja jawab, it can accommodate a larger baby. Itu saja. Okay, so that it can, it lasts longer, so that it's stronger, so that it can withstand more force. I think these are all possible good answers. You can also say another characteristic of the cradle frame is the material itself, lah, made of metal, made of steel. Okay, why? So it's long lasting, has low oxidation rate. Today I'm fighting a lot of motorbike sounds, sorry. Low oxidation rate, etc., etc. Another possible one is also use the cradle frame. The diameter of the steel is big. Okay, so you don't use a thin metal, the one use a thick metal. Okay, so the diameter of the frame is big. Okay, so that it is stronger, it is more long lasting, so that the cradle won't break when you put a large baby in it. Okay, so there are many possible answers for this. I don't think I need to write this here because I think it's a pretty simple question. But again, if you need some help okay, for this one, refer to page 30 and 31. Okay, in your black book. Okay, the answers are all there. And as I said, okay, I'm not going to give, I'm not going to give, I've already given answers. The cradle frame, just make sure you give 1 or 2 points. Just remember, okay, that, and I've seen this again and again, people will focus on the characteristics of spring and then forget about the characteristics of the cradle frame because they think, oh, saya ada 5 points dah, cukup. Cannot, even if you have 5 points, but you didn't answer the question, you cannot get 10 marks. Okay, so make sure that at least one characteristic of the cradle frame you must put in. So it's either 3 plus 2 or 4 plus 1. Okay, tetapi yang lebih penting sebenarnya, actually for me I think the more important one is, in this one that I gave just now, the first 6, okay, the first 6 characteristic of the spring are things that I think you should commit to memory. Okay, because kalau soalan dia keluar pasal Hooke's law, if it asks about the spring, okay, this 6 definitely will help you lah. Okay, you need maximum 4, but it's good to memorize all 6. And the good news is, the reason is all the same. Okay, high spring constant, stiffer spring, smaller compression. Balik. Okay, high spring constant, stiffer spring, smaller compression. Okay, one thing though that I noticed that we didn't cover here is the situation where you don't want the spring constant to be so high, but it's very rare. Okay, if you notice that all the questions kan, so far, okay, yang boleh menampung orang yang lebih berat, atau cradle, okay, that can menampung orang yang lebih berat. I think these are the more common questions now. I don't really see, okay, if it's a bungee jumping question, that is a slightly different situation. Because bungee jumping, you want it to, to be able to extend. Okay, but I think the bungee jumping question can also fall under page 31. The bungee jumping question actually came out in the trial question before. Okay, I think perhaps maybe when we go back to school, if we have time, then we will consider the bungee jumping question.